Alright guys, so in chapter 1 section 3 we're talking about slopes, lines, lines in the plane and slope as the text states. So a couple problems to kind of look at. With number 3, it says find the slope and y-intercept if possible, so of the equation of a line. So we can find this. Typically, if we have something in slope-intercept form, so the y equals mx plus b, it's a lot easier to find what the slope is and the y-intercept. So I'll make a supplemental video for that, show how to do that. But we also could get an idea of a little bit by looking at a graph. So x plus 4y equals 8. I'm going to take us to Desmos. Eventually taking us to Desmos. There we go. So x plus 4y equals 8. Again, the benefit of Desmos versus a TI, you don't have to solve it for y, you can just type the equation in. Now, so we see that the intercept there is 0, 2. But the slope, so slope is a rise over run, so it has a rise of 2 and a run of 8. So we can see that by looking at actually the two intercepts. So if I'm looking at this, I can tell that this line is going down, so I know it's going to have a negative slope. So it's down 2 over to the right 8. So that would give me a negative 2 over 8 or negative 1/4. And I believe that's what they had the answer to be. And again, the intercept was at 0, 2. So I'll do a supplemental that I'll just, I guess, do a basic solve for y to show that it's also equivalent to slope equals negative 1/4 and the y-intercept, the y value is at 2. So when we look at a y equals mx plus b form, we'll get the same answers. Another one that I wanted to kind of look at is consider the following pair of points, write an equation of the line that passes through the points. So in section 3 you're going to have the point slope form. Let's find that real quick so we can verify where that formula is at. So here's how you find slope, and then point slope form is this equation where we need 1 point, x1, y1, and 1 slope, and that'll help us find the equation of a line. I'll work one of these out. In the same video I'll work out the number 3 problem, but let's just look at what we're trying to do. I have the points 4, 11 and 0, negative 9. So again, this is something that I could graph so I could see what I'm trying to do. 4, 11 and 0, negative 9. Well, they gave us the y-intercept, so that's kind of nice. We can see these points. Either could back it up or I could change. I need my y value to go down a little bit further, let's say negative 15. And so I should see these 2 points. And I'm just trying to find the equation of the line that goes through them. Well, again, I know the y-intercept is 0, negative 9, so that means that b value, y equals mx plus b, is going to be negative 9. The slope, a little bit harder. I could count. I'm going up a whole bunch, looks to be about 20, and then I'm going over 4. So 20 over 4 is 5. That's our slope. Regression, something that you've talked about before. We could also get this equation by doing a regression and typing mx plus b. Notice that I'm using the subscripts here because my x1s and my y1s. The tilde sign means regression in Desmos. So it gives me what my slope is and my b value of my intercept. But again, I'll show you how to do it by hand as well, but this would be a great way to check our answers, is by doing a regression. Last one in this section to look at is looking at one of the word problems. Not going to do this one, but I want you to understand what you have here is a couple points. When the rent is $420 per month, all 80 units are occupied. When the rent is $465, 77 units are occupied. So that kind of makes sense. The more they charge for rent, maybe they won't rent as many of the units. But we can get an equation here, a price equation, by knowing these 2 points. The 2 points I would have, they were letting P be my X value, my independent variable. So I'd have the point 420 comma 80, and then I'd have another point 465 77. And then I would do this similar idea of, I could look at the 2 points, I could graph them, I could do that point slope formula from the text to help me find the equation of the line, or I could do a regression. Would work, something similar. So I'll make a supplemental for the first 2 questions just with a little bit of algebra, and that should wrap up the ideas of section 3.